Hello and welcome to this 14th set of problems on complex numbers. That is problem number 131 to 140. So as I always say that when I'm reading the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So without further ado, let's get started. Problem 131 says that find the intercept made by the circle z bar plus alpha bar z plus alpha z bar plus r is equal to 0 on real axis on the complex plane. So suppose there is xy axis and there is a circle which cuts at 2 points z1, z2. So we have let z1 and z2 be points on real axis which circle cuts with. Now, since these are on real axis and if z represents the point, then z will be equal to z bar because z will be x plus I0. That is, imaginary part will be 0 because the points are on real axis. So we substitute z is equal to z bar in the given equation and we can obtain z square plus alpha bar plus alpha into z plus r is equal to 0. Now, z1, z2 would be root of this equation because, as I said, z represent the points z1 and z2. So, if z1 and z2 are roots, we will have z1 plus z2 is equal to minus alpha plus alpha. Minus alpha bar plus alpha in the bracket. There is typing mistake. So, from quadratic equation, it will be minus alpha bar plus alpha, and z1, z2 would be r. Now length of intercept would be z1 minus z2 modulus of that, which will be equal to square root of z1 minus z2 whole square. Now this we can write as z1 plus z2 whole square minus 4z1 z2, which is equal to square root of alpha bar plus alpha whole square minus 4r. Problem 132 says that if a is equal to cos alpha plus I sin alpha, B is equal to cos beta plus I sin beta, and C is equal to cos gamma plus I sin gamma, and A by B plus B by C plus C by A is equal to 1, then find the value of cos alpha minus beta plus cos beta minus gamma plus cos gamma minus alpha. So clearly the given numbers are unimodular complex number, that is their modulus is 1. So we can write A is equal to e to the power I alpha, B is equal to e to the power I beta, and C is equal to e to the power I gamma. Now from the given equation, that is A by B plus B by C plus C by A is equal to 1, we can write e to the power I alpha minus beta because it will be e to the power I alpha for A and e to the power I beta for B. And similarly for B by C, we will have e to the power I beta minus gamma, and for C by A, we will have e to the power I gamma minus alpha is equal to 1. Now, if you write the real part of left hand side, it would be cos alpha minus beta plus cos beta minus gamma plus cos gamma minus alpha, which will be equal to 1. That is what we needed to find out. Problem 133 says that find the locus of the center of a circle which touches the circles z minus z mod of z minus z1 is equal to a and mod of z minus z2 is equal to b externally. So we have picked up two centers, a which represents the complex number z1 and b which represents the complex number z2, the center of the given circles, and we let P be the center of the variable circle which is touching these two circles externally. So we can say that mod of AP would be A plus R. So suppose there is a circle here and there is a circle here, and then there is a circle at the bottom. So if the radius of this is A and the radius of the bottom circle is R, then the distance would be A plus R. And for the right hand side, it would be B plus R. So mod of B plus R, BP is equal to B plus R. Now clearly the difference of these two would be A minus B. So we can say that mod of mod of AP minus mod of BP is equal to mod of A minus B, which will be a constant. Now, this will represent a right bisector, that is the locus of P will represent the right bisector if A is equal to B. And from our earlier theory, we can say that it will represent a hyperbola if mod of A minus B is less than mod of AB. An empty set if this should be if mod of A minus B greater than mod of AB. Set of all points on line AB except those lie between A and B if mod of AB is equal to mod of small a minus small b is equal to mod of AB, which is not equal to 0. Problem 134 says that prove that tan of I log A minus IB by A plus IB is equal to 2AB by A square minus B square. So to prove this, we let A plus IB is equal to R e to the power I theta. So R square will become A square plus B square. NA minus IB will be e to the power minus I theta. So we will get the tan of argument as B by A. Now we find out A minus B by A plus B, which will be equal to e to the power minus 2I theta. So we can say that I into log of A minus B by A plus IB is equal to I into log of e to the power minus 2I theta. Now the log natural is with base e. So log of e with base e will be 1, and this 2 minus 2I theta will come here. So I into I minus 1 into minus is plus. So the value which will remain is 2 theta. So this whole expression becomes tan 2 theta. And from trigonometry, you will find the formula of tan 2 theta as 2 tan theta by 1 minus tan square theta. And we have tan theta is equal to B by A. So we simply substitute and solve to get the result as 2AB by A square minus B square. Problem 135 says that Z1 is equal to A plus IB and Z2 is equal to C plus ID are complex numbers such that mod of Z1 is equal to mod of Z2 is equal to 1 and real of Z1 Z2 bar is equal to 0. Also, W1 is equal to A plus IC, W2 is equal to B plus ID, then prove that mod of W1 is equal to mod of W2 is equal to 1 and real of W1 W2 bar is equal to 0. So we are given that mod of Z1 is equal to mod of Z2 is equal to 1. So we get A square plus B square is equal to C square plus D square is equal to 1. Now we are also given that real of Z1 Z2 bar is equal to 0. That is real of A plus IB into C minus ID is equal to 0. That is AC is equal to BD. Sorry, AC plus BD is equal to 0. Now we are given that A square plus B square is equal to C square plus D square. So we bring C square this side, we bring B square this side. So we get A square minus C square is equal to D square minus B square. Now we add 2 IAC on left hand side and we subtract 2 IBD on right hand side because AC is equal to minus BD. So we get A plus IC whole square is equal to D minus IB whole square. So if you take the square root, you will get A plus IC is equal to D minus IB, or there should be space here for clarity, or A plus IC is equal to minus D plus IB. That means A is equal to D and C is equal to minus B, or A is equal to minus D, C is equal to B. Once we have this relationship, we substitute in this one and we get A square plus C square is equal to B square plus D square, which gives us mod of omega 1 is equal to mod of omega 2 is equal to 1. And real of W1 W2 bar is equal to, sorry, this should be read as W, not omega. Real of W1 W2 bar is equal to real of A plus IC B minus ID. So real part would be AB plus CD, which will be 0 if you substitute from this value and then you use AC plus BD is equal to 0. Problem 136 says that if mod of Z1 by Z2 is equal to 1 and arg Z1 Z2 is equal to 0, Then prove that mod Z2 square is equal to Z1 Z2. So we let Z1 is equal to R cos theta plus I sin theta. Now we are given that mod of Z1 by Z2 is equal to 1. So mod of Z1 is equal to mod of Z2 is equal to R. We are also given that argument of Z1 Z2 is equal to 0. That is argument of Z1 plus argument of Z2 is equal to 0. Now we have that arc of Z2 is equal to minus theta, because it will become minus arc Z1 and arc of Z1 is theta from this equation. So Z2 we can write as R cos minus theta plus I sin minus theta, which will be R cos theta minus I sin theta from trigonometry. Negative of angles of cos is equal to cos of that angle, and when sine comes, a minus sign is required. So this is nothing but Z1 bar. So we see that Z2 is equal to Z1 bar. Now we multiply this with Z2, okay, or Z2 bar. So you get that Z2 square is mod of Z2 square is equal to Z1 Z2. And that's how we arrive at the desired result. Problem 137 says that find the value of the expression 2 into 1 plus 1 by omega into 1 plus 1 by omega square plus 3 into 2 plus 1 by omega into 2 plus 1 by omega square plus 4 into 3 plus 1 by omega into 3 plus 1 by omega square, and so on till n plus 1 into n plus 1 by omega into n plus 1 by omega square. So we see that this is the first term, this is the second term, and this is the third term, and that's why this will be the nth term. So we take the nth term and we multiply all the terms. We get n cube plus n square into 1 plus 1 by omega plus 1 by omega square plus n by 1 plus 1 plus 1 by omega plus 1 by omega square plus 1. Now if you see this, the LCM denominator would become omega cube, which is 1. And the numerator would be omega cube plus omega square plus omega, which is equal to 1 plus omega square. And similarly, this will be n into omega 1 plus omega square, which is 0. So these two terms will become 0, and our nth term is n cube plus 1. So TIH term would be I cube plus 1. And summation of n terms represented by Sn is given by sigma of Ti, where I varies from 1 to n, and then we simply substitute the formula for a series with cubic powers, which is n square by n square into n plus 1 whole square by 4 plus 1. Problem 138 says that if Z1 and Z2 are two complex numbers satisfying the equation Z1 plus IZ2 by Z1 minus IZ2 is equal to 1, then prove that Z1 by Z2 is purely real. So we are given that mod of Z1 plus IZ2 is equal to mod of Z1 plus IZ2. So since this is given, the if mod of Z1 is equal to mod of Z2, we can write that Z1 bar is equal to Z2 bar. So we expand this and we write that Z1 plus IZ2 into Z1 bar minus IZ2 bar is equal to Z1 minus IZ2. This is wrong here. There is a mistake. This should be Z1 bar plus IZ2 bar. This overline should be only about Z. So then you compute this and you will find this is equal to Z1 bar, Z2 is equal to Z1 Z2 bar. That is Z1 Z2 is equal to Z1 bar by Z2 bar. This is essentially we are writing Z is equal to Z bar, and that happens only when the number is purely real. So Z1 by Z2 is purely real. Problem 139 says that if Z is equal to minus 2 plus 2 square root of 3i, then find the values of Z to the power 2n plus 2 to the power 2n, Z to the power n plus 2 to the power 4n. So the given number is minus 2 plus 2 square root of 3i, which is equal to 4 omega. So 4 omega to the power 2n is 4 to the power 2n on omega to the power 2n. And here it would be 4 to the power n and omega to the power n. Yeah. So 4 to the power n is 2 to the power 2n, and then when it will get multiplied with this coefficient, it will become 4 to the power 2n, and omega to the power n will be inside. and 2 to the power 4n is 4 to the power 2n. So we take 4 to the power 2n common, and inside the bracket we have omega to the power 2n plus omega n plus 1. Now, if you observe, if n is not a multiple of 3, then the term inside the bracket will be 0, because it will reduce to 1 plus omega square. But if it is a multiple of 3, that is n is a multiple of 3, then it will become 3. So there are two possible values. One is 0 and the another is 3 into 4 to the power 2n. Problem 140 says that if 2 cos theta is equal to x plus 1 by x and 2 cos phi is equal to y plus 1 by y, then find the values of x by y plus y by x, comma x by y plus 1 by xy. So we are given that x plus 1 by x is equal to 2 cos theta. So x square minus 2 cos theta x plus 1 is equal to 0. We solve the quadratic equation. We get x as 2 cos theta plus minus square root of 4 cos square theta minus 1 by 2. This comes from the quadratic equation solution, which is equal to cos theta plus minus I sin theta, which is a unimodular complex number. So we can write this as e to the power plus minus I theta. Similarly, y would be e to the power plus minus I phi. Once we have found x and y, it is trivial to say that x by y plus y by x, this should be x, is equal to 2 cos theta minus phi, and xy plus 1 by xy would be 2 cos theta plus phi. With this, we come to the end of 14th set of problems. If you have a comment, you can let me know, or if you have a question, you can let me know, or in case of a suggestion, please use the comment box. I hope that you are enjoying this series of videos, and if you find this video useful, please subscribe to the channel and like the video so that it can reach many more students like you, because just simply that's how YouTube algorithm works. And if you want to receive the notification of the coming videos, then please click the bell icon after subscribing the channel. Thanks a lot for watching. Enjoy.